7th grade math, test 6, study guide, problem number 1. In 2.1 minutes, you can text 10.5 words. How many can you do in 8 minutes? So what I do is I put time on the bottom to get the unit rate. I divide this, go in and out. Move the decimal one time to clear the decimal on the outside, but you got to move it inside here also in the dividend. So then I can say 21 doesn't go into 1 or 10. It does go into 105 though. So about how many times does it go in there? Well, let's try 5. There's 5, 10. Oh, perfect. So that's 5 words per minute. 5 words per minute times 8 minutes, right? Yep. So that should be 40 words. 40 words. Number 2. 40 words the answer. A factory worker can package 192 games in 16 minutes. Put the time on the bottom. How many games can he package in a minute? So unit rate, I go ahead, I divide in and out. 16 goes into 19 one time. And 16 times 2 is 32. So that would be 12. The answer is, it said find the unit rate actually. So that'd be 12. And the top number, the 192, was games, so it's 12 games. Bottom number was minutes, 12 games per minute, or each single minute. That's what unit rate means for each one, right? Number 3. The table below is proportional, so that means they're all the same. They want us to find the ratio of peanuts to raisins. So raisins got to go on the bottom. So just pick one of these right here. Actually, I'm going to pick the one with the 10. That's easy, even though they're all going to get the same answer. Because when I divide by 10, all I do is move my decimal one time. So it's 2.4 grams. And if I were to take those other two options, they would also give me 2.4. Number 4, Tony and Tiffany are collecting stones. Tiffany pays $38 for 9. Tony pays $19 for 3. So this is Tony, this is Tiffany. So who's paying the better unit price? In other words, who's paying the least amount? So if it's $38 for 9, we can find how much they're paying for each by dividing. Goes in and out, money on top, right? So 9 goes into that, 36 is the closest, so that's like $4, right? Something like that. I'm going to stop right there and see if this is bigger or smaller than 4. If this says 4 also, I'll keep going. 19 divided by 3 over here is 6. So automatically I know this is more. So Tiffany paid less. Number 5 says simplify 7 over 2/7, which is 7 divided by 2/7. Let's make 7 into a fraction, which is 7 times the reciprocal. Flip the second one upside down. Never flip the first. Cross cancel if you can, otherwise your answer is already reduced. Number 6, we have 11/5 divided by 11, which means 11/5 divided by 11 over 1, make it a fraction, right? Now I can divide fractions by multiplying by reciprocal, cross out my 1's, and my answer is 1/5. An animal can run 8 miles for number 7 in 1/4 hour. What's the unit rate? Well, we always put time on the bottom, unless the problem tells us otherwise, right? So I go 8 divided by 1/4. Again, how do I divide fractions? Sorry for the sloppy writing there. I multiply by the reciprocal. So that's just 32 miles per hour as the unit rate. So we're on number 8 now. Number 8. Select a statement that is most true. So they give us the table. We got to check to see if it's proportional. So if I put 18 over 36, and I reduce that, that's 1/2. 9 is half of 18. 45 is half of 90. So they all have the same ratio. However, if I have a 0, the other one has to be 0 too in order to be proportional. Since I don't have 0, 0, I have 0, 1. My answer is C. It's not proportional because I have 0 and 1. So the answer was C. Number 9. Which of these is proportional with 2/5? So what I do is I take 2/5 and I write a proportion with each of these and see which ones are equivalent. There's a few ways to do that. I'll just tell you the one way that we've been using in class when we're solving proportions, and that's to use cross products. So if my answer is A, then it's proportional to that number they gave me, 16 over 40, which means that if they're proportional, then cross products works. In other words, this times this has to equal this times this. There's a couple other ways to do it, but let's just use what we've been using lately. So that's 80, and 5 times 16 is also 80, so my answer has to be A. Now I'll show you how the other ones won't work. I'll just pick one. For example, B. B won't work. They're saying, is this proportional to 2/5? So I go 2/5 equals the number they gave me. And if it isn't the same, if they aren't proportional, then this times this will not equal this times this. And you can see that 60 does not equal 50, so the answer can't be B. And the same will be true for C and D. Cross products won't be equivalent. Number 10, a van travels 180 miles. On means over or per or slash 2 gallons. At that rate, how much gas will it take to travel 330 miles? So I got 180 miles per 12 gallons. I got miles on top here. So I got to put miles on top over here. 330 miles, and then how many gallons? So I got miles on top, gallons on bottom. Cross multiply, like I said earlier. If it's proportional, we cross multiply. Cross multiply. So I got 330 times 12, 2 times 0, 2 times 3, 2 times 3. Leave a spot now since we came over here, and then I go 0 times 1. And I add these up, and I get 180x equals 3,960. Divide both sides by 180. Now let's do this shortcut here. When you're dividing and you see zeros, let's divide out of 10. In other words, let's hit those zeros like that to make it easier for ourselves. For us, okay? So I'm going to divide these two, so I go in and out. 396 divided by 18. 18 goes into 39, I think, 2 times. That's 36. I subtract these two. Ooh, there's another 36, so x is 22. My answer is 22. But remember, these are gallons, so that's 22 gallons. Check our answer in the back. Always 22 gallons is correct. Next problem. We are on number 11. Number 11 says there's a 2-to-3 ratio of girls to boys. And they want to know how many boys would there be for 120 people. So they're asking how many boys for a total of 120. So I got to take my ratio and convert it to boys to total. So there's 3 boys for a total of, well, 2 girls and 3 boys is a total of 5 kids, right? So I got to add those 2. Whenever they say total, you're going to add something. You just got to figure out what to add, right? So my ratio is 3 to 5, boys to total. And they say how many boys? In other words, I don't know for the total boys, but the total number of people is 120, so I put the 120 there, right? Boys on top, total on bottom. Cross multiply. And divide. And I go in and out. So what 5 goes into that, 7 times? So the answer is 72 boys. Check our answer back for 11. 72 boys it is. Number 12. 12 says a car traveled 270 miles on 12 gallons. How many total gallons? Okay, total means we're going to add something, right? How many total gallons? So they're asking us for gallons, so we put X where the gallons goes, right? Gallons on bottom, so I put gallons on bottom. For an additional 200. Additional means I have to add. Additional means add. So I add 200 to this. 270. Cross multiply. So we're going to do alright, so I'm going to multiply 12 times 470. Go over here and multiply those two. Okay, and you should get 5,640. Divide these two. Now what? You see those zeros? Cross those out. Okay, so now I'm going to do 564 divided by 27. So 27 is going to go into 56 2 times. Subtract. Sorry, there's a 2 there. Now 27 doesn't go into 24, so I have to put a 0. Now I have to put a decimal because I'm going to add zeros after that. 27 goes to 240 about 8 times. 8 times 27 is like 216. I can stop right there because 20.8 is about 20.8. And the question was how many boys? It's about, wait, I'm sorry, wrong question. The question was how many gallons, right? Round to the nearest whole number. Yes, gallons. So that's about 21 gallons. About 21 gallons. 21 gallons. Okay, 21 gallons. About. Because you round it. Number 13. So number 13. We're going to find the constant rate of change. So they're telling us already this is proportional. Just pick one. Okay. Put time on the bottom. It goes on top in the table, but when we find our unit rate, time goes on the bottom because time decides stuff, right? So it goes on the bottom. So just put 19 over 1. That's it. That's the unit rate. 19 over 1, which means 19. Okay. And 19 feet per minute, number 14. So that one was pretty simple. Pick the easy one, the one with the 1 in it, right? The one with the 1. Number 14, find the constant rate of change. So if it's proportional, which I see is the straight line that goes to the origin, all I got to do is pick one point. You see that point right there? It's 175. That's the point. 175. That's 1 point. So I put y over x. Just like I did in the last problem. It goes x, y, I put y over x. The same stuff. So I get 75. There's my unit rate. 75 what? Well, we put this on top, right? So it's miles per hour. 75 miles per hour is the unit rate. MPH, miles per hour. Number 15. Juan earns $7 per hour. That's his unit rate. At his job. Which ordered pair would not appear on a graph showing how much Juan earns in X hours? So if it's on a graph, you're not going to have to do all this work. I'm just explaining this. If it's on a graph, remember, money's on top. Money goes over here, okay? Money goes over here. Time is X times on the bottom. Time always goes down here. This is a money for symbol if you're wondering. So time goes here, okay? All right. So, on a graph, it goes X and then Y. So when we get our unit rate, we put money on top, time on the bottom. Money on top, time on the bottom. So I'm gonna look at these coordinates that would be on this graph that when I put y over x, I still get 7. So if I'm looking at 15, if I put 21 over 3, that's 7. 14 over 4, let's think about that. Let's reduce that. That's not 7. 35 over 5, well, 35 divided by 5, that's 7. And 7 over 1 is obviously 7. So the only one that wouldn't work would be B. Number 16. It says which value would complete the table to make the relationship proportional. Okay? So we're looking at these. These are all proportional. That means they're all the same. So let's just take one. Always use the one with 1, right? 22.4 over 1 means our ratio is 22.4 to 1. So this one right here, what's missing is the y. We have the x, we need the y. But these are all proportional, so let's write a proportion. So I got y is 22.1, x is 1. Let's put y over x, and we'll put y over x. We're going to put y over x equals, we're missing y, so I put y over, we have this x, 3. So just write a proportion with any of them, and you can get the right answer. So I cross multiply, I go 22.4 times 3. Pretend there are no decimals, right? I'm just multiplying 224 times 3. So I got 12, 6, 7, 6. Then I count all the decimals for both numbers, and from the right I add them in. So this times this is 62 and 2/10. Y times 1 is just y. That's it. I'm done. See, it was smart to use the 1. If I'd used some of the other ones, I would have a different coefficient, different number in front, which I have to divide by, but when it's all said and done, I would still get the same answer. Answer, 67.2. Number 17. Alright, let's finish this bad boy. Number 17 says, where am I at here? Tell whether the graph represents direct variation. That means is it proportional? So obviously, yes, because it's a straight line that goes to the origin. Direct variation means proportional. And then it said give the equation. Well, we learned in class that giving the equation just means put y equals our unit rate x. And that's what we just did earlier, right? Unit rate, y over x. So I just take any point. I see a point right here on the lattice. Lattice means where the lines meet, right? So the coordinates for that are 1, 4. 1, 4. I put y over x, and I have my equation, y equals 4x. Number 18. And I could have used the other points, 2 over 8, right? Or 2, 8. 2, 8. If I put y over x, I still get a 4, no matter what points I use. They're all the same. Constant rate of change. 18 says, Monday through Friday, a student spends 33% of his time sleeping, 30% of his time at school, 8% of his time practicing a sport, and the rest of his time is using other various activities. So if I add this up, I get 11, 71%. If everything else is various activities, and they ask what percent of time is various activities, well, altogether it has to add up to 100. So all I do is add these numbers up, subtract it from 100. Okay, and that should be what, a difference of 29? Let's check our answer. All right, 29%. Next one, number 19. What number is 35% of 86? Remember, it goes is over of, right? I put percent with 100 always, and I put is over of. So what number is, I don't know, is 86% of part, whole, cross multiply, and divide. I got 100x equals 86 times 35. And okay, so I go over 86 times 35. 30, carry my 3. 8 times 5 is 40, add the 3 is 43. Leave a space. I got 18, carry my 1, 24 plus 1 is 25, 0, that's 11, carry my 1, that becomes a 10. So I got 100x equals 3010. Now I divide both sides by 100. The beautiful thing about dividing by 100, we just move the decimal 2 times, so that's 30.1. And that is done, and that was fun. Let's do number 20. Number 20, 20 is 25% of what number? This time I don't know the of, so I put the x down there, right? Is over of. Percent always goes over 100. I multiply these two. I had 3 zeros. 1, 2, 3, right? 25 times x is 25x. Divide both sides by the coefficient, right? Not by this one, by the one in front of x. That's what we divide by. And it goes in and out. In and out. And then 25 goes into 200. Think of money, quarters, right? How many quarters in $2? That'd be 8. And then that's 200, but you got to finish it out, so the answer would be 80. And we're done. All right, hope that helps.